This video is on hydroboration-oxidation on triple bonds. The reaction works really well on alkynes too, but as with the oxymercuration reduction, we will form a ketone due to the enol-ketone tautomerization. So for example, if we take this internal triple bond, react with borane and THF, followed by hydrogen peroxide and sodium hydroxide, we end up with this ketone via this enol intermediate. So, knowing that this reaction is anti-Markovnikov, what would you expect to happen if we do this reaction on a terminal triple bond? Pause now to draw a tentative product. Okay, so if you drew the aldehyde, well done. That is what I was looking for, but you are wrong. The problem with the alkene borane intermediate that is formed is that it is more reactive than the starting material. So instead of all the borane reacting with the triple bonds, you'll form this borane that is more reactive and therefore will react with another borane to give you this diboranated alkane. So it turns out making aldehyde is more difficult than making the ketone. Boo. Well, this is a problem, but at the same time, it can be solved. The borane can be modified to make it much more bulky so that a second addition just does not fit on that carbon. Right? We disfavor the double addition. So how do we do that? Well, if we have two equivalents of an alkene reacting with a borane, we can make this diisoamylborane. Notice that it only has one hydride left. It's also very bulky. So if we now were to react this reagent with a triple bond, the bulk will prevent a second addition to the terminal alkyne, and therefore we end up with this borane at the end, which we can then replace with the hydrogen peroxide to give us our aldehyde. How did we get the aldehyde? By the enol intermediate, of course. Turns out this is a whole branch of organic chemistry where if you need a selective reducing agent, you just modify your reagent into something bulkier. Anyway, you have a go. What would be the products of these following reactions? You may pause now. And here are the answers.